Hello viewers, I am Kausalya. Today we are going to solve problems related with RL transients as well as RC transients. So here the problem is, in a series RL circuit shown in figure, the applied voltage is given by this term. Find the resulting current and the initial rate of change of current. Right. So here the first thing is we have to find the current. And the next thing is rate of change of current. What do you mean by rate of change of current? You have to differentiate it with respect to time t. Right. So here this is a given circuit diagram. So the first step is, as usual, you have to apply KVL. Right. So when you apply KVL, sum of voltage rise is equal to sum of voltage drop in a closed circuit. So here the voltage drops are produced by this resistor and inductor. So voltage drop across resistor is given by I into R, and across the inductor is given by L into di by dt. Right. So just write down the expression I into R plus L into di by dt, which is equal to your source voltage E. Right. The next thing is we are going to substitute the respective values. So here the value of R is 50, the value of L is 0.5, and the source voltage is 100 into e to the power minus 50t. Then the next step is we have to take Laplace transformation. So once you take Laplace transformation, you see I becomes I of s and di by dt becomes s into I of s minus I of 0. This minus I of 0 denotes the initial voltage, right? Initial voltage across your inductor. Since nothing is given in the problem, the initial voltage across the inductor is taken as 0, right? And when you take Laplace for this expression, it becomes 100. This 100 remains here, and e to the power minus 50t becomes 1 divided by s plus 50, right? So the next step is we are going to take I of s commonly outside. So when you take I of s outside, this is our expression, right? The remaining things remain as such. So here, when you rewrite an expression for I of s, so I of s is given by 100 divided by, sorry, here s plus 50 is missing. 100 by s plus 50 into 50 plus 0.5 s, right? So again, as usual, we always need only s plus term, but here we are having 0.5 s, so I am taking this 0.5 outside. So when you take this 0.5 outside, this becomes s plus 100 and this s plus 50 remains here. Now again 100 divided by 0.5 is 200, right? So this is our final expression for our I of s, right? Now the next thing is we have to take partial fraction. So since the denominator has two terms, we will be having two individual expressions for it. So A and B. Again, when you take LCM, this is our final equation. So here we have to find the values of A and B. So the same thing, when you substitute s is equal to minus 50, A becomes 0, we can find the value of B. So when you substitute it as minus 50, the value of B is 4, right? And the next thing is we have to substitute the value of S as minus 100. So that B becomes 0, we can calculate A. So just substitute the values and finally the value of A is minus 4. Right. Now substitute the values of A and B in this expression. So when you substitute, you see this is our expression. So what we actually need, we want transient current, that is I of t. But here we are having I of s, therefore take inverse Laplace transform. So when you take inverse Laplace transform, you see this minus 4 remains here. So 1 by s plus 100 becomes e to the power minus 100t. Similarly, here 4 remains here and s plus 50 becomes e to the power minus 50t, right? So here just I am rearranging, right? That is I am bringing the positive term first and then the negative term. So here in this expression 4 is common. So when you take outside, this is our final expression for our I of t, right? So we have calculated the resulting current. Now the next thing is we have to find the rate of change of current. Okay, that is initial rate of change of current. Therefore, here we have to differentiate this expression and we have to equate the value of t as 0 because initial rate of change, right? Initial means when time t is 0. So here when you differentiate, you see e to the power minus 50t, when it is differentiated, it becomes minus 50 into e to the power minus 50t. Similarly, e to the power minus 100t when differentiated becomes minus 100 into e to the power minus 100t. Right. So here this minus into minus becomes plus here. And when you substitute the value of t as 0, e to the power 0 is 1. Right. So our expression becomes minus 50 plus 100. So 100 minus 50 gives you 50. So 4 into 50 gives 200 amps per second. Okay. This is your initial rate of change of current. Right. This problem gets over here. We will proceed with the next one. Our next problem is an exponential voltage is applied at time t equal to 0 to a series RC circuit comprising R equal to 5 ohm, C equal to 0.1 farad. Obtain the current I of t. Assume zero charge across C before application of the driving voltage. So here this is an RC circuit and we are having a source voltage. Okay, and there is no initial voltage across the capacitor. Okay, that is what mentioned here. Assume zero charge across C. Right. So here this is your circuit diagram. So as usual, the first step is we have to apply KVL. So when you apply KVL, you see this will be our expression, right? Voltage drop across resistor plus voltage drop across capacitor is equal to the supply voltage, right? So here I into R plus 1 by C. Again, since we are having capacitors, and also you just make it clear, if there is zero charge across capacitor, you can skip this expression if you are clear with this. Right, you can directly write this expression and this expression alone. If you have any doubt, you just write down the entire expression, and here there is zero charge across the capacitor before application of voltage. That is, it indirectly means that is the initial voltage across the capacitor is 0. Therefore, this expression reduces to 0. Right. Therefore, here you see I into R plus 1 by C integral of 0 to t I into dt equal to V of t. So this is our expression. If you are clear, you can directly write this. Okay, no need of this. Now the next thing is we have to take Laplace transformation. So when you apply Laplace transformation, you see this expression, okay, this becomes I of s into R plus 1 by C. The value of C is 0.1 farad. So just 0.1 into I of s by s, and when you take Laplace transform of voltage, what is the value of voltage here? Here the voltage is 5 e to the power minus t. So 5 e to the power minus t becomes 1 by s plus 1. Right. So the next thing is we have to take I of s commonly outside. So when you take I of s, this is your expression. Now the next thing is we have to take LCM. So when you take LCM, it becomes 5s plus 10 by s, which is equal to 5 by s plus 1. So again, when you rewrite the expression for I of s, so I of s is equal to 5s divided by s plus 1 into 5s plus 10, right? That is, here this term, when it is moved to the right hand side, we have to write it in the reciprocal format, right? So when you write it in reciprocal format and arrange, this is our expression. Again, you see here I am having 5s, but I want only s. So here I am going to take this 5 outside. So when you take this 5 outside, what do you mean by that? That is, we are dividing, okay? So dividing and multiplying by 5. You can take it in any way, right? So here in this case, you see, here we are multiplying the term by 5 and here we are dividing by 5, right? So when you divide it by 5, what happens? This becomes s plus 2, right? So here we are having, you see, s plus 2 and this 5 remains here. So again, these two terms cancel each other, and finally the expression for I of s is s by s plus 1 into s plus 2. So the next step is we have to apply partial fraction. So when you apply partial fraction and once you take LCM, this is our expression, right? Again, here we have to find the values of A and B. So just we substitute the value of S equal to minus 2, we can get the value of B. Similarly, when you substitute S equal to minus 1, we can get the value of A, right? So the value of A and B are given. Now, when you substitute this value in the expression for I of s, you see this is our expression, right? So the next thing is we have to take inverse Laplace transformation. So when you take inverse Laplace transform, 1 divided by s plus 1 becomes e to the power minus t. And here 1 divided by s plus 2 becomes e to the power minus 2t. Right. And this minus 1 and 2, these are all the constants which will remain here. So the final expression for I of t is just you have to rearrange. So 2 e to the power minus 2t minus e to the power minus t. Right. So here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.